Lesson 13.4. Evaluate inverse trigonometric functions. Find an angle whose tangent is 1. Well, if we think about our special right triangles, and tangents opposite and over adjacent, if we had one where the two sides were the same, wait, what one is that? That's the 45. So 45 degrees. Oh, but pi over 4 is the same as 45 degrees. Or could be 5 pi over 4. Or it could be negative 3 pi over 4. There's a lot of different. In order to find angles given sides, we have to define the functions carefully so that we have only one output. Inverse trigonometric functions. Inverse sine of A is the ratio of the sides, equals our angle. You use the inverse to find the angle. When you're looking for the angle, you use the inverse. You only use the inverse to find the angle. The only time you use the inverse is when you're looking for the angle. Inverse sine always gives you an angle between negative pi over 2 and positive pi over 2. That's one quadrant where sine is positive and one quadrant where sine is negative. It's positive there, it's negative there. Inverse cosine gives you an angle between 0 and pi. That gives you a positive angle and a negative angle, because sine is positive over there. And inverse tangent gives you an angle between negative pi over 2 and positive pi over 2. Again, that gives you a positive quadrant and a negative quadrant, because cosine is positive down there in quadrant 4. So remember that that is the ranges of the inverse trig functions. We're not doing an inverse cosecant, inverse secant, or inverse cotangent. They exist, we're just not doing them. So evaluate this expression in both radians and degrees. Inverse sine of square root of 2 over 2. Yes, I know you can just type it into your calculator, but let me show you how to use the special right triangles. If we unrationalize that, we end up with 1. So we multiply the top and bottom by the square root of 2. We end up with this. Oh, that gives us a special right triangle where if I use this as my angle, the opposite is 1 and the hypotenuse is square root of 2. This is opposite over hypotenuse. So what angle is that? Oh, that appears to be 45 degrees or pi over 4. How about inverse cosine of 1/2? So we think, oh, it's 30, 60, 90, because this is my 1 and 2. And cosine is adjacent over hypotenuse, so I need an adjacent. The 1's adjacent, the 2's the hypotenuse. And you think, okay, so if that's the adjacent, that would be the angle. So it's 60 degrees, which is the same as pi over 3. How about inverse tangent of -1? Well, we could think of that as 1 over 1. So we have the opposite and adjacent. So opposite over adjacent. So it's 45 degrees, but it's negative. So that means on our unit circles down here, and in that quadrant, tangent is negative, so it's a negative 45 degrees, or negative pi over 4. Solve this equation for theta. Cosine of theta equals 0.4. Well, you have to think. If I'm looking for my angle, what do I use? That's right, use the inverse. So it'll be inverse cosine of 0.4. All right, inverse cosine is 0.4. Put it in my calculator and I get 66.4 degrees. How do I know I'm using degrees? Well, if you look up there, it says 270 degrees and 360 degrees. That's a big hint. You should be in degrees. So if you're not getting 66.4 degrees, check the mode of your calculator. You will have to keep switching back and forth between degrees and radians, depending on your problem. We still have a problem here, though, because 66.4 degrees is not between 270 and 360. So I'm going to go ahead and draw an angle in quadrant 4, because that's between my 270 and 360. But the reference angle has to be 66.4. Remember, the reference angle always goes to the x-axis. And then, using the 360 and 66.4, we can find our angle. Subtract them, and you find our angle is 293.6 degrees. So we're going from here round to there. Let's try another one. Tangent of theta is 4.7, and I want the angle between 180 and 270 degrees. All right, so I do inverse tangent, 4.7, and my calculator says that's 78.0 degrees. Well, that should be in quadrant 3, because it needs to be between 180 and 270. So there it is. Okay. So using the 180 and the 78, should I add or subtract? Are my angles getting bigger or smaller? Bigger. All right, so I need to add those together, and you get 258.0 degrees. Let's try one more. Sine of theta is 0.62. So I do inverse sine of 0.62, and I get 38.3. All right, so that's in quadrant 2 because it's between 90 and 180. So I want an angle in quadrant 2. The reference angle is 38.3. That goes to the x-axis. So I can use the 180 and that 38.3. Now, is that angle going to be bigger or less than 180? Less. So we'll subtract. Get 141.7 degrees. All right, little simpler ones going back to geometry. Find the measure of angle theta. So you look at this and say, oh, what sides do I have? This would be the adjacent, and this would be the hypotenuse. Adjacent and hypotenuse are cosine. Cosine of theta is 4/9. Since I'm looking for the angle, do the inverse. Inverse cosine of 4/9 is 63.6, according to my calculator. One more. All right, here, this one appears to be the adjacent, and this one is the opposite. Opposite and adjacent. Let's see, opposite and adjacent. That's right, it's tangent. So to find our angle, do inverse tangent of the opposite over adjacent. Inverse tangent 10/8. My calculator says is 51.3 degrees.